All right, if you remember how to do composite functions, f of g of x and g of f of x, then you can verify that any two equations are inverses of each other, or you can prove that they're not. If you can do a composition functions, plug one into the other, and you get the answer y equals x, then you will know that you have found inverses of each other. Because remember, that's how you create an inverse, right? The y's of one are the x's of the other. So the y's do literally equal the x's. So we have to remember, it's been a while since we did this. So if you can plug the g into the f, and everything cancels out but the x, then you're halfway to proving. So for this first one, if we do, f of g of x, then we would get 2 times 1/2 x minus 2 plus 4. And then we have to do the algebra on that, so we would have to distribute the 2. 2 times 1/2 is just 1x, or x. 2 times negative 2 would be negative 4. Then we have plus 4. So the 4's will cancel out, and we would have x. Okay. We should verify this the other way around, though. We should also plug f into g and make sure that's going to work. So that would be us doing g of f of x. So we would have 1/2, and then the parentheses 2x plus 4. And then after the parentheses, subtract 2. Oops, I forgot my equal sign, didn't I? So we distribute the 1/2. 1/2 times 2 is just x. 1/2 times 4 is 2. And then beyond the parentheses is minus 2. So the 2's cancel, and we get x. So because we got x both times, the equations are proved to be inverses of each other, because each operation in there cancels another one out and leaves us with just the variable. All right, let's try this next one. If I put g into f, it would go right here where the x is. So I would have negative 4 times 1/4 x plus 3. I would multiply my negative 4 and my 1/4 together, so I'd have negative x, and then I'll have plus 3. And that's the end. So I know that these are not inverses because I did not just get x by itself. I am unable to undo all my operations. So I know that these are not inverses. I don't even have to complete it. Okay. And now for the last one. If I need to find out if g plugs into f and cancels out, it'll go right there with the exponent on the outside. So I would have the square root of x minus 5, still have the squared, plus 5. Remember that x is greater than or equal to 0 is just a domain statement for the graph. We don't need it here for our solving. If we square a square root, that will cancel out. So we'll have x subtract 5 plus 5. So the 5's cancel out, and we'll just have x. Or, if we check it the other way around, I suppose I should say and, not or. If we put x squared plus 5 in for x, it'll be inside the square root. So I'll have x squared plus 5 where the x used to be, then subtract 5. I really don't need those parentheses, so I can get rid of them. Ooh, that kind of messed up my writing though, didn't it? So let's try that again. There we go. The 5 and the negative 5 will cancel each other out, so I'll have the square root of x squared, which cancels itself out. So I'll just have x. So because I was able to cancel out and get x's in both places, I have proved that the original two equations are inverses. If you have questions, please let me know.